What if I told you that the biggest map in the entire universe is being drawn by the smallest things in it? Across the vast, dark canvas of our galaxy, there's an invisible dance happening right now. And it's all powered by the faint, ancient light of distant stars. It's a dance that holds the key to seeing the unseen. So, that brings us to the big question, right? How in the world do astronomers map these enormous, invisible magnetic fields, the ones that stretch between stars and literally sculpt entire nebulae? I mean, how do you even begin to draw a map of something you can't see?
You're probably thinking the answer has to involve some gigantic telescopes or, super complex space probes. But the real secret, the key to this whole mystery, lies in something almost impossibly small: cosmic dust. Yep, that's right. Tiny, irregular grains of dust, smaller than a grain of sand. These are the microscopic messengers that let us trace the galaxy's hidden architecture. And it all, and I mean all of it, comes down to one simple fact: these little particles are spinning. Okay, so what gets them spinning in the first place? Well, the answer is surprisingly elegant. The engine that drives this whole cosmic choreography is the very thing we see lighting up the night sky: the light from stars themselves. The core concept here is something called radiative torque. We all know that light is made of photons, and when a photon hits something, it gives it a tiny little push. But for these dust grains, it does way more than just push. It creates a twist. This is the motor that gets everything started. And this is just a brilliant illustration of why that twist even happens. The absolute key is the grain's irregular, kind of potato-like shape. See, if it were a perfect little sphere, Starlight would just push it along in a straight line. No drama. But because it's asymmetrical, light hits all the different bumps and angles unevenly, which forces it to spin, almost like an unbalanced tire on a car. And we're not talking about a gentle tumble here. Not at all. The constant stream of photons from countless stars acts like this relentless engine, accelerating these tiny grains to truly, and I mean truly, mind-boggling speeds. Can you even wrap your head around that? We are talking about millions of rotations every single second. It's a supersonic spin, all powered by nothing more than the gentle, persistent pressure of starlight playing out over eons. Just amazing. So, you might be wondering, why don't they just spin faster and faster until they fly apart? Well, it's kind of like a car hitting its top speed. Out there in space, there's a tiny, tiny bit of resistance from stray gas atoms, and that provides just enough friction to create a perfect balance, capping the speed at this incredible rate. Now, this is where it gets really cool. This isn't just random, chaotic spinning. All of that energy forces these little dust grains to align themselves in a very specific way, essentially turning each and every one of them into a tiny beacon, pointing the way for us. So the first step in this alignment process is just pure physics. You've seen this before, like a spinning coin that always settles flat, or a figure skater who pulls their arms in tight to spin faster and more stably. The dust grain does the exact same thing. It naturally settles into its most efficient state, rotating around its shortest possible axis. But here's the crucial part. Most of these dust grains have a little bit of iron inside them. And when you spin that iron at millions of rotations per second, well, it's kind of like rubbing a balloon on your hair to create static electricity. That incredible spin awakens a weak magnetic property inside the grain itself. It's a phenomenon called paramagnetism. And now we have the final piece of the alignment puzzle. The spinning grain has become a tiny magnet, and just like a compass needle here on Earth always wants to point north, its axis of rotation is slowly but surely forced to line up perfectly parallel with the vast, overarching magnetic field lines of our galaxy. So let's recap. We've got trillions of dust grains, all spinning supersonically, all perfectly aligned with an invisible force. The big question is, how do we actually read this map they're creating? This is the payoff, where this microscopic alignment lets us finally see that galactic scale structure. Okay, let's put it all together, because it's just wild. First, Starlight provides the engine that gets the dust spinning. Second, that spin and the iron inside create a magnetic alignment. And third, that alignment has a direct, measurable effect on the very starlight that passes through this dust on its way to our telescopes. So here's how it works. Because all the grains are lined up the same way, they start to act like a cosmic picket fence for light. Light waves that are vibrating in one direction get blocked,
but waves vibrating in the other direction can pass right through. It's exactly how your polarized sunglasses work to cut out glare, but on a galactic scale. I just love this quote because it paints such a perfect picture, doesn't it? Trillions upon trillions of microscopic dust grains, each one a tiny engine, all snapping to attention, spinning in perfect formation. And by measuring that polarized light they create, we can finally see the unseen.
It just makes you wonder, doesn't it? The solution to one of the biggest mysteries in astronomy was hiding in the spin of the absolute smallest particles. What other massive secrets of the universe are hiding out there in plain sight, just waiting for us to find the right way to look?